If you're interested in producing an intelligent method of measuring temperatures remotely in a non-contact way and recording date, time, and temperature, and also with the option of adding other sensors, then this is the video for you. Let's do a demo. This is the sensor over here. This is the real-time clock. I'll put my fingers up near but not touching the sensor, and oh, I'm a little bit warm. Hopefully I'm not running a fever. Maybe I'm a little too close. But yeah, 36, 97, 98. Yeah, so that's pretty much it. The benefit of this one is that you do not have to have it attached to a computer. This will operate remotely. I'm using the serial display, and I'm also using the non-contact sensor, the 90614. I'm using a real-time clock, 3231, and the 9548. This is the I2C bus expander. And then, of course, the Arduino allows me to add intelligence to this setup.
Let's take a look at the hardware. As you can see over here, this is a photograph of the actual circuit. It's kind of messy. We'll cross-compare it over here to the circuit diagram, which is a lot easier to follow. The main components are, of course, the Arduino here. And the Arduino here. Here is a 9548, and this is a bus expander for the I2C bus, and that's this device right here. This is the LCD screen, which is down here. This is the real-time clock, which is that thing with a black lump on it. And then this thing with a little bullseye is the MLX90614 infrared non-contact sensor. What we have is we have the 5-volt power supply from the Arduino coming over here, and it goes into this breadboard, and it's going to power all the devices. So you can see the negatives here, the positive is here, and again everything is connected through that. The 9548 gets its data and clock lines from the Arduino's A4 and A5 pins, and they come over here. On this side we can see those as this is the A4 line coming in as for data, and this is the A5 as the clock line, and again the power, 5-volt power and ground. On these others I've abbreviated the power and ground to kind of keep things a little clearer. But these all attach back to here via the breadboard. Okay, next on our list is the MLX90614 infrared sensor. The yellow line goes to SD0, and that is over here. There's the yellow line, and it's from SD0. And of course it is the data line, and it goes to the data line over here on the 906. The orange wire goes to the clock line on the 9548, and that is from here to here. Going down to the DS3231, that's this device. The green wire comes over here to the SD1 port on the 9548, and the clock line is the orange wire that comes back, and it's harder to see because it kind of wraps around this way to right there. Finally, we have the LCD screen. The green wire comes down here, it's the data line, comes down here to the SD2, and yeah, this one curves around quite a bit, comes over here to the SD2 line, and then the yellow line is the clock line, and it comes back over here, and we see that coming to the SC2 connection here. And that's pretty much it for the hardware. Yes, it looks very messy over here, but when you lay it out, it's not so bad, okay? This is the software that makes all the magic happen. I have videos that have tremendous detail on some of these different components, like the TCA9548, the MLX90614, and the DS3231. So I'm going to go over these rather quickly, and I'm going to focus on the commands that have to do mostly with a liquid crystal because I don't have a video on that yet. This is the code. It's written in C for the Arduino, and we are going to focus mostly on the LCD display parts of the code, but it also includes the MLX90614, this is the infrared temperature sensor, the DS3231 real-time clock, and the TCA9548 bus extender, which is this device right here. The first line of code here is to include the library for the I2C bus. The next one is to include the library for the liquid crystal display. This is to create a nickname and also to set up the default address for this 16 by 2 display. This line of code is for the to create a name for the TCA9548 default address. So the default address is 70 hex. This is to include the Adafruit MLX90614 library. And this line is to create a nickname so that I don't have to retype this whole string every time I use it, like down here. And it also sets the address to the default of hexadecimal 5A for that device. This is to define the name for the DS3231 and the default address of 68 hexadecimal. This is a declaration of some byte variables: seconds, minutes, hours, day of week, date, month, year. And then this last one is some doubles, temporary values for the temperature in centigrade and temperature in Fahrenheit. This is our setup routine as required by the Arduino. The first thing we're going to do is tell the Arduino which device on the 9548 we're going to select. And in this case, it is the MLX90614 that is in position 0. We can see that. And so then we say, okay, MLX begin. So we're going to initialize the 90614. The next thing we're going to do is we're going to select the device number 2, which is the LCD screen. And we're going to initialize it, and that comes from the library. And then we're going to turn on the backlight for the LCD. So that's what's happening here. This little bit of code right here has to do with our TCA9548. This is the bus extender, and it's just a routine. It's going to accept the device number, which is this I right here. If the I is too big, so it's greater than 7 per this, it's going to reject it. It's going to return. Otherwise, we're going to open the I2C to the 9548. This is a little clever bit of code that does a left shift by 1. It multiplies by 2. And then this is the end wire transmission, which forces the data transmit back from any device on the I2C, but in this case, again, it's the 9548. Here is where we read the temperature from the infrared sensor. And first what we do is we tell the TCA9548 which device it is. So it's right here, it's 0. And then we go about our business of grabbing the data from that. So we read the object temperature in centigrade and store that here. And then our temporary Fahrenheit is here, and we get that information here. So we just call this routine, and it's a double. So if you want to modify the code, remember that's a double. The next thing we do is we do the TCA select 2. So we are going to grab this right here. We're going to tell it to use the LCD device. My comment is wrong, please make note of that. And then we are going to put the cursor to the first position on the last row, which is down here. And obviously we're not printing out hello world, but yes. And then we are going to print the temperature in centigrade, and then we're going to follow that by a C. We're going to print some spaces, and then we're going to print the temperature in Fahrenheit, followed by an F. So that's where those lines of code are coming from. Okay, so let's move down. This is our most complex code, and again, I've got a video that goes over this in great detail. This is getting our time and date back from the real-time clock, and it's rather complex. It uses binary coded decimal and so forth. This first routine, what it does is it converts binary coded decimal to decimal so that we can do regular math with it. I won't go over this again in detail. I keep repeating myself, but that's in another video how I explain this inner workings of this. And then we come down here and we do a get real-time clock time. So this gets us the seconds, the minutes, the hour, the day of the week, the date, the month, and the year. And this first statement right here tells us to go to the TCA1, which of course is our real-time clock. The rest of this is just as if the clock was attached to the Arduino directly. And we do the begin wire transmission. We feed it the address of the device. Then we do a wire write, which sets the register for the clock to 00. We do an end transmission, which is a weirdity about I2C. You tell it to stop sending, and then that's when it sends the data. So this is the request from this address, this device's address, for 7 bytes. Then we get the seconds by doing this, and we get rid of the upper order bit because we don't know what that is. We grab the minutes from the next byte, hours for the next byte, and here we get rid of the 2 high order bits for the same reason. We get the day of week from the next byte, date from the next byte, month from the next byte, and year. We get 1 byte, and that only goes from 0 to 99, so make note of that. Next is another DS3231 routine, and this actually is where we print out the date and time, and this is what it takes to format it nicely. So we take the seconds, minutes, hours, day of week, date, month, and year that we got from up here, and we do the TCA select 2 over here. So this is to print out to our LCD screen. And then we use our LCD set cursor to 00. So we're going to go to position 1, which would be up here, the top line. We print the year, and if the month is less, so that is just like 20. The next one is the month, and if the month is less than 10, we want to pad that out with a 0. So then we print the month. Then we go to date, and if date is less than 10, we pad it with a 0, and on down here, so hour, minute, seconds. So this makes our date and time beautiful. The last thing down here is the main loop, and we just print time, so it calls this routine, which in turn calls that routine. So that is all of our date, time, information we're getting back and printing. And the next one is the read temperature, which was this routine up here. And then we delay for 1 second, and that is pretty much it for the whole program. So as you can see, the LCD is very easy to use. It's 90% of this code is because of the other devices we're calling on the I2C bus. Okay, well that's it. I hope you found that useful and interesting in your Arduino software and hardware programming.